Hey, we're going to do another polynomial example. This example is we're going to look at a cubic polynomial, order 3 polynomial. It has general coefficients a3 times x cubed, a2 times x squared, plus a1 times x plus a0, the constant. Now I'm going to say, let's assume here that this polynomial let's see if we can find the coefficients. If we say the polynomial is going to pass through these 4 sets of points. For a cubic polynomial with 4 sets of points, it is possible to determine the 4 coefficients, the 4 unknown coefficients. Now, sometimes you can have 4 sets of points where you can't do it because the points may violate the condition of the polynomial, may not give you enough information. But usually with 4 sets of points, you can do this. Certainly you don't need more than 4 sets of points. So our first point is x equal 1, y equal 4, then x equal negative 1, y equal 0, x equal 2, y equal 15, x equal negative 2, y equal negative 5. So let's see what these 4 points give us. So I plug in x equal 1 and y equal 4 into this equation for the polynomial. So y equal 4 is equal to a cubed times 1 cubed, which is 1, plus a2 times 1 squared, which is 1, so we get a2, plus a1 times 1, which is a1 plus a0. So the first point here gives us this equation that must be satisfied by the coefficients a0 through a3. Now let's plug in the red point right in here, and then we write down the red equation. X is equal to negative 1, y equals 0, so we get y equals 0 equal to a3 times negative 1 cubed. That's a negative a3. A2 times negative 1 squared. Negative 1 squared is 1, so that's a2 plus a2. Then plus a1 times negative 1, which is minus a1, and then plus a0. A0, bring that down. So the red point gives us this equation that must be satisfied by the coefficients a0 through a3. Let's look at the yellow point. Y equal 15, x equal 2. So we get 15 equal to a3 times 2 cubed. 2 cubed is 8, so that gives us 8a3. We get a2 times 2 squared. That gives us 4a2. We get a1 times 2, that's 2a1 plus a0. So the yellow point says these 4 coefficients must satisfy this equation. And then finally, the blue point here, negative 2, negative 5, gives us this equation if you plug it in. Okay? So we have 4 equations, all of which must be satisfied by the constants a0 through a3 that are the coefficients in our cubic polynomial. Okay, so I need to solve these 4 equations for a0, a1, a2, and a3. So I'm going to begin that process by taking the green equation and the red equation and simply adding them together. So I'm going to add these 2 equations together. 4 plus 0 gives me 4. An a3 and a minus a3, a negative a3 added together gives me no a3. a2 plus a2 is 2a2, so that's this term right here. a1 minus a1, that gives me 0, a1, and then a0 plus a0 gives me 2a0. So adding these 2 equations together gives me this equation right here. Must be satisfied by a0 and a2. Now let me add these 2 equations together. I add them together. 15 minus 5 is 10. 8a3 minus 8a3 is 0. 4a2 plus 4a2 is 8a2. 2a1 minus 2a1, this is an a1 here in case it's not clear, is 0. And then a0 plus a0 gives me 2a0. So I add these 2 equations together, gives me this result. So now we have these 2 expressions, which I have now copied up here, except with this equation right here, I've divided it by 2 on both sides to give me 2 is equal to a2 plus a0. This equation I've divided by 2 to give me 5 is equal to 4a2 plus a0. So now I have these two equations directly from these two. Okay, so these two up here give me these two equations up there. Okay, now I take these two equations and I'm going to subtract the top one from the bottom one. 2 from 5 gives me 3. a2 subtracted from 4a2 gives me 3a2. And a0 from a0 gives me 0. So I get 3 equal to 3a2, and which is pretty straightforward, gives me that a2 must equal 1. Well, if a2 is equal to 1, I can go back and put 1 in this equation for a2, and I see that a0 must also equal 1. So I get these two equations, or these two values, for a0 and a2. Okay, now let me now see, with these two values for a0 and a2, can I go back plugging into these equations to give me a1 and a3? Well, if I plug into the first equation, because that's the simplest one, I have 4a3 plus a2, which is 1, plus a1 plus a0, which is 1, and that gives me 2 equal to a3 plus a1. Okay. Now if I plug into the red equation, okay, I get 0 equal to negative a3 plus a2 here, which is 1, minus a1, this is a1, plus 1, because a0 is 1. So this is plugging in a2 equal 1 and a0 equal 1 into the red equation, and I get 2 is equal to a1 plus a3. Well, this is the same equation as this one. So I can't solve these two because I've only got one equation and two unknowns. Let's try the yellow equation. I get 15 equal to 8a3 plus 4a2, and a2 is 1, plus 2a1 plus a0, which is 1. So I get, so I have this 4 plus 1 on this side, and I'm going to subtract that 5 from both sides. That gives me 10 is equal to 8a3 plus 2a1. That's after I've got rid of these two constants here and here. That's where the subtracting 5 from both sides. I can, so I now have this equation for a3 and a1, and I have this equation for a3 and a1. So I can subtract this equation here. I subtract the red equation from this yellow equation. Okay, that gives me 8 is equal to 7a3 plus a1. So I now have my two equations and two unknowns. I have this equation and I have this equation, which are not the same equation, and I can solve those for a1 and a3. I don't go through the details, but here's the answer. a1 is equal to 1 and a3 is equal to 1. So it is possible then to solve using 4 points. We can find 4 coefficients. Okay, and this is generally true. If we have a 4th degree polynomial, we need 5 points. If we have a 5th degree polynomial, we need 6 points, because a 5th degree polynomial will have 6 coefficients. Remember the a0. So here, this is a general rule that depending on the order of the polynomial, we're going to need that many points plus one more to be able to determine the equation of the polynomial, determine the coefficients of the polynomial. Okay, now let's say here we have our answer. We have y is equal to x cubed plus x squared plus x plus 1. So this is the polynomial that we have that goes through these 4 points. Let's see if I plot that out. Here's a plot of that polynomial, x cubed plus x squared plus x plus 1. See, does it go through the 4 points? Does it go through the point x equal 1 and y equal 4? Well, let's see. This is x equal 1 right here, and this would be y equal 4 right here. So it looks like it goes through that point. Does it go through the point negative 1, 0? Say if this is negative 1, then this is 0, so it goes through that point. Does it go through the point 2, 15? 2 would be here. Actually, I can't tell if it goes through 15. It looks like it does, though. And does it go through the point negative 2, negative 5? So I go here to negative 2, which is, this is 0, 0 right here. This is the origin, negative 1, negative 2. I go down here. Indeed, it goes through the point negative 2, negative 5 right here. Okay, so a plot of that polynomial verifies that it is correct and that it goes through the points as we have specified. Okay, until next time.